This question is taken from the ENGAA 2020 section 1 paper, and it is question 17. A spring has natural length 0.1 meters and spring constant 20 newtons per meter. The spring hangs vertically with a mass of 0.05 kilograms attached to the end. The mass is pulled downwards until the spring has length 0.3 meters. The mass is then released. What is the speed of the mass at the time the spring returns to its unstretched length? So what method should we use in this question in order to work out the speed when it gets to the unstretched length? So normally you could try and do this either in energy or forces, but forces would be quite difficult to use because the force will keep changing depending on the extension. So the method we should go for is energy. So energy would be the best way to do this. So in order to answer this and get a grip of the question, we should draw the setup like this. So when it's pulled down to 0.3 meters, and then when it's at 0.1 meters, the unstretched length. So we'll need to work out what energies there are at each of these points, and then be able to deduce the kinetic energy so that we can get the speed. So in order for simplicity, we'll take at 0.1 meters, when it's unstretched, we'll take this as 0 GPE, so we can have the kinetic energy as the only energy here. So no elastic potential energy or gravitational potential. So the energies will be minus 0.05 times 10 times 0.2, so a negative GPE, and then half times 20 times 0.2, the extension, squared, and then 0 GPE here, but some kinetic energy. So the kinetic energy when it gets to here must come from the initial energy when it was at the bottom, the 0.3 meters. So this kinetic energy is half times 0.05 times v squared, which is equal to 0.4. So half times 20 is 10, times 0.2 is 2, times 0.2 again is 0.4. Then take away 0.1 coming from the gravitational potential energy. This is 0.3 joules. So the velocity squared, if we rearrange this, is 0.6 divided by 0.05 is 12. So taking the 2 over to that side to get the 0.6. And then simply we can read that the velocity must be square root of 12 meters per second, as the answer gave. So some answers may have given 2 root 3, and then you would have needed to simplify this third more, but the answer simply wanted square root of 12 meters per second as one of the suggested answers. So the velocity at the instant the spring returns to its unstretched length is square root of 12 meters per second for this mass.